have Dr. Mary Matthew, who is Associate Professor at Department of Management Studies at Indian Institute of Science, who will be moderating this session. We have on dais as panelists Mr. Raghuveer BK from Infosys Product R&D Unit, who is the head of Communication Products Group. And we have Mr. Vinod P. Deshmukh, President Technology and Products PES, that is from Mindtree. And then we have Mr. Ganga Prasad, who is Senior Scientist and Associate Director CDAC Bangalore. I'm not getting into the details as we have already been delayed quite badly. I leave the floor to Dr. Mary Matthew to take over the panel discussion.
Thank you so much, Raji. I'd like to, at the outset, thank the BCIC for giving us a slot and for encouraging us to have this consensus and feedback session. I'll just give you a background of what we're going to do. This particular panel session is based on a study that we had just completed, commissioned by the European Commission, and the study aimed at understanding what India wants to do in ICT R&D, and mind you, it's R&D, not per se ICT. What India would like to do for ICT R&D in the next 2 and 5 and 10 years. And so we've just completed a particular survey, and I'll show you a little bit of that on a slide. And what I'm going to ask my panelists here is to sort of respond to our findings. So to do that, what I'll do is to first show you some of the findings, and like Raji said, because there is a shortness of time, I'll not get into the details of why this particular study was commissioned, but I think Katya already gave you a little bit of a picture that European Commission is interested to partner with India, especially on ICT R&D, and ICT being the flagship in the sector of the country. There is scope for India to partner with European partners, and they wanted to know what India would want to do in this context, and that's how this study was commissioned. So let me just quickly take you through a couple of slides. Is that on somewhere, the slides? Yeah, thank you. The next, thank you so much. So the study, as you can see there described, aimed at understanding what India would like to do in ICT, more or less a foresight study. That is, we are trying to see what we will do in the next 2 and 5 and 10 years, and about 30 visionaries. Again, I'll not get into the details of sample, but there were about 10 leading academicians in ICT space. There were about 10 SMEs and about 10 large companies that participated on this, mostly CEOs and CTOs at the top management level. And all of them sort of gave us inputs as to what they think would be the technology priorities that India would focus on for R&D. And that is what we had done. I think I have some of the details on it in the next slide. Thank you so much. Yeah. Now, one interesting thing before getting into the technology priorities that we noticed that experts said is that India would focus on ICT R&D in a particular manner, a little different probably from many of the other developed countries and probably some of the other developing countries, that it would be definitely low value and high volumes. So the low cost is going to be a focus of Indian ICT R&D in a big way. Another point to note of is the aspect of low energy consumption and green solutions with regard to ICT technologies. And another suggestion which is very much core to India is that the dominance of software rather than hardware solutions to the same issues that can be solved. And another thing was the whole thing of rural focus, and which is of course reaching the whole thing to the last mile and solving problems at the rural markets, as it were, and in which case of course the language diversity comes into picture. These were some things that were really general, that kept on echoing across the survey that we were doing. And in the next slide I have the classification that we arrived at, which is a broad classification, as you can see, of technology priorities. The first classification is core ICT technologies, and the second classification are ICT for sectors and ICT for applications. In other words, after we have content analyzed about 30 video recordings that we have on the ICT visionaries, we have arrived at this classification, and I'll just take you through some of these technology areas in a minute. Yeah. So if you look at the core technology areas, I think some of these were being mentioned in the sessions that were going on prior to this one, and internet access and all technologies related to bandwidth, spectrum, all of that was something that was very much echoed in many of the visionaries. Another one, of course, is networking of machinery, and I'll speak a little bit more on that. Of course, the whole thing on cloud computing, which was mentioned already again, SaaS and the deliveries of those kinds of ways of delivering software, smart networks, especially in the context of energy, and then we have different kinds of aspects of focus on embedded systems and other technologies. On the next slide, Raji, please. Thank you so much. Another one that is noticeable is monitoring systems, both low-cost cameras and low-cost sensors, and aspect of developing better performing sensors that are not energy consuming and things like that, and security systems and security algorithms. Now these are, as you can see, not per se applied to a sector, but these were like core technology developments that one would focus on. Now, especially the audience seated here, I am told, are more or less academic teachers, students, and some industry personnel. This might give you insights as to where to focus on projects and things like that is something that I would think. In the next slide, we have some of the sectors, which is more to do with healthcare, and as you can see, the sector that emerged most popular amongst the visionaries was ICT for healthcare. And there are many aspects of ICT technologies related to health care that you can think of, and these are again an important area that students, faculty can think of with regard to projects, something that India really needs. I won't go into details because I think my panel members are slightly aware of these kinds of technologies. They've already seen this slide, and the next sector area was energy. So ICT for energy, whether it's smart grids or ICT for solar panels or any such thing, was also one aspect that they kept mentioning. And yet another was with regard to any kind of ICT solution, you got to get conscious of making it both green and energy low on energy. The whole thing is this, that if we consume energy at the same rate as which the developed world has consumed it, this kind of country consumes it in that rate, it's all going to be a bit of a crisis. So I think India is very conscious, at least experts are conscious, that India would develop ICT solutions which are low energy consuming. The last sector that they had mentioned was, of course, governance and education, which is a popular sector mostly with the government. And one would see from this sector that it's not necessarily that we will always go to European Commission for sponsoring projects in this area. Possibly some of these would be in-house sponsored. It's not necessarily that we would look for funds from European Commission to do projects in this manner, and these may be things that are going to be domestically funded, as it were. The mobile was a mentioned device that is coming, which was commonly running through most of the visionaries, and they were very conscious of the fact that the mobile is going to become a device of centricity, in the sense everything is going to come, whether it's healthcare. Also there was a whole consciousness that even BP monitoring or any such thing should come and get centered around the mobile device, and not just have multiple devices that a person has to carry around. So the mobile and mobile applications certainly was an important aspect, echoing through the core technology development as well as applications in different sectors. This is the basic heads up I'll give you with regard to our report. Of course, our report has a whole lot of other things, and what I'm going to do is to ask my expert panel over here to sort of comment on what they think would be some of the technology priorities as they see it. Now, the point to mention is that the panelists sitting here with me just now did not participate on the study, and in other words, we would have an external validity from people who have not participated on the study, trying to say that, yeah, I think maybe this is what I would focus on, or whether or not they agree to what we have just communicated. And I'll ask Raghuveer to mention what he thinks could be the priority areas.
Thank you. So I think a lot of the points that are there in the presentation are valid. What I would want to do is very quickly put a theme around my thinking in terms of what we need to prioritize from an India point of view. There are three grand challenges India is facing today and will continue to face for the next 50 years. right? One is the use of natural resources, or even the derived resources. We would probably have 1 billion people wanting to consume the natural resources or the derived resources, and as of now we know that a small percentage of the country is actually consuming most of these resources, and the rest of them are not actually consuming it, because you can't go ahead and expect a poor villager to be consuming electricity the way we do here in the metros, right? So, but when they start consuming water or electricity or fuel or any of the other derived resources, we will have a serious issue. That's a grand challenge. The other problem that we have, and we will continue to have, is education and quality of education. It's not because of infrastructure and multiple things, it's just the scale that we need to manage as far as the country is concerned. You will have different levels of educational institutes, location issue, language issue, multiple issues are there. The third grand challenge is obviously healthcare. Multiple reasons, and all of us know, so I am not going to explain on that. These are the 3 grand challenges. Right? In these 3 grand challenges, what is that we need to do? Across all these 3 grand challenges, there is a very common thread that runs through all of them. One is any natural resource needs to be measured, monitored, controlled, in addition to creation if possible. Right? So we need to go ahead and have the ability to measure the usage of natural resources, have the ability to go ahead and analyze the usage of natural resources so that we can optimize the usage of that. In addition to going ahead and trying to create new ways of doing it. Once you go ahead and measure it, be it your fuel consumption, food consumption, or anything else, you would have to analyze it, and there are multiple instances where measuring it properly and making it available makes people think about utilizing it better. So classic examples, you have a counter at the traffic signal, it shows 120 seconds or whatever, and people switch off their vehicles to conserve fuel. There's a good company in Electronic City which has a container where the leftover food is put in the cafeteria on a weighing scale. So, and I'm told that the amount of food wastage drastically reduced because people would every day see that the amount of food being wasted is in the range of 100 plus kgs. Be it your BP, sugar, whatever, it has to be measured. Once it's measured, it can be controlled. Once you have measured, you collect the data. How do you collect the data? You can't obviously collect the data in a distributed manner, you collect it in a centralized manner. Right? So you need to have the analysis, compute and the analysis infrastructure that is required. How do you do that? You need to have connectivity to be able to do that. Right? And once you have analyzed all of it, you can go ahead and optimize it by various mechanisms. So effectively measure, collect, analyze, and the feedback will goes in. This is across the grand challenges of the consumption across all kinds of natural resources. Education, we need to go ahead and understand what we know, what we don't know. There are mechanisms that need to be put in place to ensure that somebody in a tier 2, tier 3, tier 4 education institute in a rural area understands what more they have to learn. So in order to do that, we need to have a lot of research that goes into measuring usage, be it water table, be it fuel consumption, be it food consumption, anything, right? And then we have to have mechanisms to collect it. The only way to enable collection of all of this is through connectivity. So connectivity is a very important issue in that context, so that's been brought up here. Both wireless and wireline technologies are important. And the ability to go ahead and analyze the data, and that is basically analysis of big data or large volumes of data, and that is whether it's a cloud infrastructure or the analysis on top of cloud infrastructure, but basically you need to have large amounts of compute infrastructure that is to be available. So to some extent, most of these are covered, but the broad 3 themes which I would see running across all of them is to have the ability to measure everything, ability to collect it, and the ability to analyze and feedback it.
Yeah, maybe we'll ask Ganga Prasad, coming from the government side.
Yeah, good afternoon. I would like to mention a few points. Before that, we are just here to talk about the India ICT cooperative program. I was fortunate enough to be part of a number of key experts meetings held in several parts of India for several number of years in connection with FP7 and whatever the future plans for FP8, various programs and things like that. So in that context, probably I would like to mention a few points, and then maybe at the end I will just connect with a few points and how the large part of the audience, the education side, the faculty, the professors and the students and others are there, how they can get connected with this particular aspect. I would like to open with a comment that recently you might have read in the newspaper, heard our Honorable Prime Minister talked about how India is lacking in certain very high-end technologies and what will be the priority areas in the government of India, and mentioned one particular point which is very relevant for our work, my work and our CDAC's work is been doing from several years, like, is that in the next 12th 5-year plan, and of course followed up with 13th 5-year plan, the government of India is going to dedicate at least 10,000 crores in investing into the high performance and supercomputing technologies. This is one of the very important aspects. I would like to say why it is important is because that we are all moving towards the cloud computing. Most of you are aware of it actually. Cloud computing is something which is going to, when it is in full steam, it is going to reach the mass in the speed which no other technology has reached. That's the kind of thing. I mean, today we have seen the mobile technology has reached, especially in Indian context, the most rural areas also. Like. So with reference to that, the EU and the India collaboration, a lot of things that can be done in this particular area. India has got a lot of thrust put into that. I mean, none other than Prime Minister himself has mentioned, and there are several. But at least I can tell about 5 to 8 research organizations are working in this direction. One very important aspect which is required is the underlying communication fabric, for which the National Knowledge Network is already in place. It is, I should say, about 10% is already in place. I mean, progressing very well. I mean, in the last 1 year itself, they have progressed 1% to 10% and slowly progressing across the country. And most part of the research and governmental institutes have been connected today. And the next step is they are going towards private educational institutions and private entrepreneurs to be connected under the National Knowledge Network. So with that, the large supercomputers, large computing environments will be made available, will be accessible to large community. So this is one area. There's a lot of research that need to be done, and a lot of collaboration that can be established. Another aspect which Prime Minister himself has mentioned a little while ago, and of course it is going to get launched in the 12th and 13th 5-year plan, is there is a target of 500 million skilled manpower development program likely to start from next year, targeted by 2022. So you can imagine when you talk about 500 million skilled manpower development, it's not a very easy thing. In the classroom type of education or the contact type of education program, if you do whatever will be the kind of level, whatever will be the importance that is given, it is very, very difficult to reach that. So ICT intervention is a must in that particular angle. So e-learning and various CPDs, various new technologies or content delivery through internet and mobile technologies, whatever the new ideas and innovations have to come in this particular direction. So a lot of research opportunities are there in this particular direction. So educationists and institutes will have to pool in and come out with some innovative methods using ICT technologies to reach this kind of targets. And another major area is, of course, we are also working in that area, is the smart grid technologies. See, once the ICTs were thought to be till little while ago was in the area of banking, finance, governance, and only these aspects. But utilities were they were shy of using these kind of technologies. But there is the time has come very close to that, and then all utilities have to embrace these ICT technologies. They have to optimize, and with the kind of limited resources which are available, especially the countries like India, will have to embrace these kind of smart technologies, smart grid technologies, where we are talking about some of the states, if I am correct, 30 to 40% energy losses are there. I mean, both technical and commercial losses is around 30 to 40%. Even if you just ICT technology is used, and if you are able to save some 20-30% of that, itself is a very great advantage. So it requires a lot of research and collaboration between EU and India. There is a great opportunity in that particular direction. And lastly, to mention, India specific thing is that India is a multilingual kind of environment. If ICT has to reach the masses, obviously we have to go in the local language, speech model and things like that. So I don't want to go details about that, but certainly there is a huge amount of research opportunities are there, collaborative opportunities, because even Europe also has got a multilingual kind of environment. So individual country might have a single language probably, but Europe as together there is a number of languages, kind of problems that we have, the similar type of problems that they would have. Maybe for kind of speech, I mean there are literates are more, but in India we might find it less. But in terms of languages, we have such kind of problems. So with these points, I would like to conclude right now.
Mr. Kangaprasad, you mentioned supercomputing to me. I think did you forget to mention? You want to highlight that part?
Oh yeah, that's what I just mentioned about the government of India has committed to be 10,000 crores in building the supercomputing technology in the area of petascale computing and hexascale computing, large-scale computing environment. That throws again the problem of, because when we go for a larger computing environment, it consumes lots and lots of power. One estimate says that one hexascale computing engine would require something like about 1,000 megawatt of power. When it's going to consume 1,000 megawatt, you will have to have a huge generating station attached to a computing environment. So we have to think about innovative methods of bringing it down to by 1,000th time or even 1,00,000th time of power consumption and having a high computing power. And that's where the success of cloud computing is going to come.
Yeah, thank you. Mr. Vinod Deshmukh, would you like to state your points?
Okay, thanks. I will be brief actually here, and this is about the EU-India collaboration and priorities for the ICT. And as all of us we know, actually the ICT plays a very dominant role in almost every industry that we can think of. And so going through the list, actually it is difficult to say that I will add something more in the priority list over there. It's already a lot of things are covered. And possibility is that we may have to prune a little bit and may focus on few areas rather than all of it. But if I have to go back and I take it the point from what Raghuveer started with, what are the India's priority? First of all, I look at actually when it is a partnership and a collaboration, it has to work more on, you could say, like the strength of each partner. And if I have to look at actually the EU and India, I would put, some of the academicians here may not like it, But I would put it that actually when Dr. Matthews put it, that there are core technologies and there are application areas, I think that in the core technology we have to do a lot of catch-up work. This is a fact. We are very sparsely represented in any of the standards body. We very rarely work on very advanced research areas, both at the academics or in the industry. Industry is abysmal, actually less than 0.1% of their money they spend on the research. So we should look at actually if we are not good at that. But on the other hand, we may be very good at the application side, the applications which are required. And another thing about the application thing is that these applications are context specific. So same the e-governance thing may not work as it is in India, or the same e-learning may not work, what works in the EU may not work as it is in India. And so if we fund our research more on the application side, that would be an added advantage, and it may be a win-win. We learn from their e-governance part, we do our own, and then collaboratively we enhance our entropy, so to say, knowledge entropy over there, and that's what I would do. But if I have to go down and put my fingers on, say, two technology trends which are currently there, and one of course is a big data. That's what people talk about. What is big data? They say that the today's tools and the technologies cannot handle that data. It is very complex, it changes very fast, it is voluminous, and it has a variety. I think that that would be area in the poor, because India would generate humongous amount of data, as we know, whether it is in the UIT program or whether it is in any program that we can think about in India. Maybe an area that we should go and research. Other things people talk about, and then we must also think about the trend, is the things of Internet things. So I think that's where we think actually within next 4 to 5 years, almost 5-fold number of network devices will be connected together, and that would require actually a different way of handling. We also know that in next 5 to 10 years the bandwidth will go maybe 1,000 times. It would require a different way of handling both the signaling, the control, and other things. Those are the area in the core that I would look at. When I come to the application side, and I think a lot of good things are mentioned in terms of the e-health and the e-governance, which are very important. I would club most of them into what I will call it as a social infrastructure, ICT for social infrastructure. And one of the things I feel which is very important for us, partly it is touched by Raghuveer, but it is, in my opinion, in terms of how do we utilize the ICT in our planning process. More importantly, when we talk about the urbanization is happening in India. Why it happens? I think the things are very clear. It is a place where the wealth is generated, it is a place where the entertainment happens, and so everybody wants to move there. Can we reverse this trend with the ICT technology? Can we plan the cities and then the mega cities based on ICT, do those simulations for our requirements, our needs, which would be very relevant. We talk about actually e-education, and most of the thought goes in terms of how do we create the content and how do we deliver the content. But if I have to take the very good example, what happened in the India in the last decade, and the cell phone example, everybody takes it. But what was the problem? The problem was that A wanted to talk to B anywhere in India. And I think that with the cell phone, with the wireless communication technology, we could get rid of the physical copper wire. My thought process, and that's what I would recommend, is in terms of the education is a need, so was the communication and talking to the other person. But can we reduce the need for the physical infrastructure in communication, but at the same time provide the same or the better experience to both the teacher as well as to the student? And I think those are the areas which may be our own specific things. We have to deliver in multiple languages, we have to deliver at multiple strata of the people, multiple levels that they learn. And I think that is where our research focus should go.
Thanks, Vinod. I would like to say that whilst we were doing this study, there was a view that India would be more focused on applied areas and less on what is called core ICT areas. Because if you study the way Europe and North American economies are growing and technologies are growing, there would be a fair amount of R&D investments in core ICT there, and a fair amount in also sector, and it's kind of well balanced. But there was a feeling here that we would be a bit more sector oriented, and we were quite happy when we noticed that a lot of experts were talking about core ICT, which means ICT for the sake of the development, the aspect of ICT technologies, and not specifically an application. And later on someone would take that and apply it, and that is how R&D of course evolves from basic R&D through to applied R&D. We noticed that balance also existing in India, and that was a good thing that we thought. Given the fact that most of the panelists here, rather all three of them here, constantly mentioning large data, and all of us know that large data would go across many kinds of sectors, especially healthcare or education or even energy for that matter, I would like to ask the panel whether they could sort of put a kind of timeline on how we go about this whole large data development aspect, and cloud computing for that matter, which is tagged in there, simply for the for the fact that developing this needs to be planned. And we noticed also when we were doing the survey that the whole concept of planning, what will we do in 2 years, what will we do in 5 years, or what will we do in 10 years, is not very clear, and it's a bit of a hazy thing. If one has to develop a roadmap or a trend study, one needs to have clarity on milestones and what one would achieve in sort of periods of years, as it were. And maybe I could throw that back to the panel, if you can just focus down on only the large data aspects of cloud and all of that kind of thing. Connectivity of course has to be again thrown in, but what kind of, in 2 years, 5 years, 10 years, how would one look at what should we focus on first, what should we look at next? Is there some clarity in that, and can anybody highlight that aspect? Raghu, you want to go first? Yeah.
Sure. So let's look at each one of them one by one. The massive amounts of data that could be generated, but first thing is you can't collect data because connectivity is not there. And then if you have connectivity, you might not be able to analyze because the compute infrastructure might not be there, right? So it's a sort of a chicken and egg issue, and we need to break it somewhere. So one of the things that needs to be done is to ensure that connectivity infrastructure is there, and this has to be done from a point of view of building up core technologies out of India for India's requirements. Traditionally what's happened is any technology that comes in from outside India lags the technology cycle by 5 to 10 years. And in a lot of cases, even if it comes in here and grows pretty well, right, you have multiple other issues. For example, we have 500, 800, whatever billion cell phone users, right? Just look at it. The quality of your cell phone voice traffic is so bad that it gets disconnected every 10 times you're going on a, wherever, even if you're stationary for that matter, right? So there's a quality issue. Why is there a quality issue? Maybe the cell phone networks or the cellular networks should be built a little differently for India, where the density is extremely high, rather than the way it is being built out for the rest of the world, where the density is slightly different from the way it is in India, right? So there is a need to go ahead and develop these core technologies, and connectivity is the first thing that needs to be tackled, right? And that has to be done now. That is something which is badly required. It's a sad state of affairs that even today all the large programs that the government is announcing, be it the National Knowledge Commission, be it anything else, there's absolutely no focus on either encouraging or using indigenous technologies in the process. Right? Somewhere the start has to be made, and it's the government which has to make the start. Connectivity is the most important thing, that's got to be started now. Right? Immediately after that, probably in the next couple of years, we need to have massive centralized compute infrastructure. It might be a supercomputer, it might be a cluster, it might be a bunch of data centers and a whole lot of blade servers that are put in out there, or it might be distributed across the country. But that massive compute infrastructure is required within the next 2 years. Once you have connectivity and compute infrastructure, you will be able to collect the data and then analyze the data, and that's when the big data analysis comes in. That's probably something which has to be done in 3 to 4 years time frame. I think that's how I look at it.
Okay. Well, what about you, Vinod? Do you want to quickly?
Yeah, I will very briefly actually, maybe I will take a different view. I think big data is today also. You know how much data Facebook generates or what Google does actually. Maybe 50 billion transactions every day on the Facebook that happens, or it is like petabyte of data which is handled every day by the Google. So today I think a big data is handled, but the point is actually that today's tools may not be good enough to handle that, and there may be innovation, there may be new things that the people can think about, how to extract the information from the data which is generated. This is what all about actually the ICT can do. I would put this as 3 parts actually. One is data generation, and which could happen through sensors. Means there is a seismic data from the Himalayas, and maybe there are tens of thousands of sensors over there which are there. You get real-time data there. What do you do with it? Data. First of all, you transmit it, so that's what he said actually, communication infrastructure has to be good. But the later part comes more in terms of analyzing that data, and that is where lot of innovation can happen, and which could be very sector specific, very problem specific, and that is where academics can get in. And it is whole lot of actually algorithm that is called analytics, data analytics over there, which is a big buzzword today. But this is very important. When the large data comes in, you can find out in that large data some pattern, and which could be useful for one segment of the people versus another segment. Same data can be dissected, and that is what the different tools can come in, different research can get in. Whether it's a medical data, whether it's education data, whether it's seismic data or whatnot.
Yeah. What about you, Professor?
Sure.
Yeah. See, there are many things which are involved in that. When you are talking about a time frame, if you go sequentially, step by step, for example, you develop the communication infrastructure, say it will take about next 3-5 years, let's say. Then after that, you want to develop the computer infrastructure, another 5 years. It goes on like that. And by the time you have that, our requirement would have grown multifold. So probably you have to have a holistic view of various things, like 3 things. One is the language technology, the second one is the network, the communication technology, and the third one is the computer infrastructure technology related. There are so many things associated around that. So we have to have innovative methods, and a lot of research has to go into that direction. It's not just only development today. So simply a development is not going to be a use at all. So we have to have a multi-pronged approach, and that is where this collaboration is going to help. In all the 3, what I have mentioned is that that collaborative across the nations, like EU, India cooperation, India-US cooperation, any multinational kind of collaboration in the research area is very important. I mean, there is no 2 words about that. I would say.
Thanks. I think it will take a longer time before we can converge with a timeline, so I will not spend time over it, but I think it must have been a little clear to the audience that the ICT spectrum is so huge and large, although it seems to be, just one of the many technologies that we have today in the world of science. But it seems to be all pervasive, and it is touching all kinds of fields, and it's a very complicated area to actually classify. And when we just tread on one, which is large data management and access, and then we come and realize that everything is so interrelated, you need connectivity in place prior to that. And I hope that the young people sitting in the room sort of got some ideas about what they can do with large data analytics and building algorithms around that, and that's something that they can take home today. So let me just quickly wind up, because I know Mr. Sampath is on pins here with time, and I don't see where he is, but I must thank him for inviting us once again and allowing us to have time to share with you what these findings are. And I want to thank these expert panelists who have taken their time off to be here to sort of comment on this kind of finding, and I think that's a real opportunity that we had listening to them, and I hope that there was something to take home for all of you. Thank you so much.
Thank you very much. Yes, I wanted to
points towards the meeting. First of all, I am extremely thankful to all the panelists and the chairperson, Dr. Mary Matthew, for having this different perspective, because since morning we were talking about something, now we have got an international perspective on future ICT priorities for India. So it is an away from the main subject. Thanks, and I must express a sincere thanks to Surabhi and Rajeshri for participating in this program. May I request Surabhi to hand over mementos and blow out the chamber to all the distinguished people. First, Dr. J. Matthew.
Thank you very much, Mary, for the meeting.
Mr. Naburi.
Thank you very much for being part of our.
Mr. Vinod Deshmukh. Mr. Kalwa Prasad.
Thank you.
Thank you all. Let us give a big hand to each other.
Thank you so much.
Thank you.
So we come to the conclusion of the technical sessions. So I know you are all been sitting since morning 9:30. It will be a very, very long day. So we don't want you to stress too much. So may I request Ms. Revati Kasturi, founder and CEO Lux, to come up to the dais. I may also invite Mr. Navneet Mishra, Mr. C. Nagendra, Mr. Sanjeev Varunde, Dr. Mary Matthew once again, please, and Mr. Raghu Bhargav. This is basically, she is going to summarize today's event, and then I will